for this problem, we also need to identify the vertex of a parabola, but notice that the parabola is not given to us in vertex form. It's actually given to us in sometimes what is referred to as standard or general form. It's given to us in the form y equals a times x squared plus bx plus c. And when we're given the parabola in this form, we can identify the vertex based on the values of b and a by substituting them into this little formula negative b over 2a. So here our vertex, the x-coordinate would be negative 2, the opposite of 2 is negative 2, over 2 times a, and in this case a is negative 1. So we have negative 2 over negative 2, which is 1. And then to get the y-coordinate of the vertex, we'll actually substitute 1 in place of x here and in place of x here. And when we do that and do a little bit of evaluation, we get that the y-coordinate of the point is 25. So our vertex is at the point 1, 25. And this will help us to identify the range, because essentially what this means is that our parabola has a vertex somewhere up here at the point 1, 25. And we know because the coefficient, the value of a here is negative, that our parabola would be frowning. So our range is the possible y values. The highest possible y value is at this peak here, 25. The lowest y value is negative infinity. So our range can be written that y is less than or equal to 25, or it can be written with interval notation. If you're not familiar with interval notation, there's no need to be concerned with that. You'll learn about that next year in pre-calculus, or in the fall in pre-calculus. The other item we need to identify here is the y-intercept. The y-intercept occurs when x is 0. So if we put a 0 for x here and a 0 for x here, we see that the y-intercept is simply 24. So right here is our y-intercept. Our y-intercept is at the point 0, 24.